What is up, guys? Welcome back to another video. Today we're going to be trying to solve, or more likely I'm going to show you how to solve I to the I. What is that equal to? So let's start off. So an important thing that you need to know is the following property, right? If we have, say, ELN to the 4, that is going to be equal to 4. And I'm going to actually show you that. So let me just open my calculator real quick. Next, no, back, next, yeah, there we go. Sorry about that. If we have this, right, and let me just turn on and off and on again so we can be in the menu. Oops, menu 1. If we write e to the power of ln of 4, this is going to be 4, as you guys can see. So it's as easy as that. It's a property that you need to learn. So yeah, coming back to the exercise, we can simply say, hey, that's the important thing that you need to know. That's it. So let's proceed with the exercise. This, what can this be? Well, if we take a look at this, we can simply say, hey, AE is ln to I, right? And everything to the I, right? That's something we can do. However, now we can simply say EI to the ln of I, right? That's it. However, we really don't know what ln of I actually means. And that's when it comes to we get to issues. So yeah. Okay, so I'm just coming back to it. Now we have this, right? But we want to know what ln of I means. Well, we're first going to start off by checking this out. We know that sit, right, is basically going to be A plus BI, right? Which can also be translated as R cosine of angle plus I sine of angle, right? However, check this out. Sit, well, this thing can also be seen as EI of theta, right? So we're going to write that. Sit is R times EI of theta, right? And now we can simply, check me out, we can simply write ln on both sides. So ln of sit is going to be equal to ln of R times E to the theta, right? This can be equalized as of R times E I of theta. Sorry, ln of EI of theta, right? That's basically what we want. Now, ln of EI of theta is going to be basically just 1. So we're going to simply have basically ln of sit, ln of R times I of theta, right? Because this cancels out. The E and the ln cancel each other. So now that we have this, we can simply proceed to write ln of I is equal to ln of 1 in this case. Why 1? Because 1 is basically our R. So if we check R, right? You can check R of this case, R of A plus BI. It's going to be basically 1, right? So we can simply just write that. Plus I of theta, which in this case is going to be pi halves, right? So we can simply say that ln of I pi halves, basically. That's pretty much it. So now that we have that, we can simply just write that into our original function, which is going to be EI, right? Pi halves of I. This translates to I squared times I halves. This basically translates to E minus pi halves, which translates to basically that, E of minus pi halves. So that's how you solve this exercise. Now, maybe I didn't explain it as detailed as I could, but I'm gonna provide a video on the description below that you guys can watch. It's another explanation for another guy, and he explains it way more thoroughly. So yeah, watch that. Thanks for watching.